Okay, so let's suppose if there is a magnet moving through the coil, or if there is a conductor which is going to be held in a magnetic field, and when we try to move that conductor in a magnetic field, so in both cases there will be an induced EMF, right? So let's suppose if we first talk about the factors affecting electromagnetic induction. So on which factor electromagnetic induction depends? So first discuss about that. So first topic is related to factors affecting electromagnetic induction, right? So any idea that on which factors the electromagnetic induction will depend? Let's suppose if we take
Current?
the example, okay, the value of current. But in induced EMF, we are going to induce the value of electric current, right? Before that, there will be no flow of charges in the circuit because no DC or AC source is connected in the circuit, right? We will induce
Yes.
EMF with the help of magnetic field, right? By changing the magnetic field, either we can just move the magnet into the coil, or we can move a conductor between the magnetic field. So both are the options. So you need to know about that on which factor the induced EMF or the electromagnetic induction depends, right? So it means that we are going to discuss about that if we want to find out, or if you want to know about the value of induced EMF, either the induced EMF is greater or less in quantity. So on which factor does the value of EMF or electromagnetic induction depends, right? So initially there will be no value of electric current. Okay. So first, if we take the example of a magnet through the copper wire or any coil which is in a circular form, right? Let's suppose if we move the magnet through the coil with very high speed or with very low speed. So is there any effect of the speed of magnet or the speed of the movement of magnet between the coil? Let's suppose if you move that magnet very fast through the coil, or similarly, in the second case, if you move that magnet very slowly through the coil, so is there any effect on induced EMF or not?
Yes.
Because if you move magnet very fast through the coil, so there will be quick change in the magnetic field, right? And last time we discussed that induced EMF is due to the change of magnetic field in the coil. So if there will be a quick change in the magnetic field, so the induced EMF will also increase and decrease with the reference of speed of wire or speed of magnet, right? So the first factor we can write as, we are talking about the magnitude of induced EMF depends upon, because these factors are very much important, just like the factor affecting the resistance we discussed in the previous chapter, that resistance depends upon the length and cross-sectional area, right? So if we increase and decrease the length, so resistance will also affected by the length. And if we increase or decrease the cross-sectional area, so the value of resistance will also increase or decrease, right? So same goes for the factors of induced EMF, right? So the very first factor that affect the value of induced EMF is known as the speed. So we can write as it depends upon the speed at which the wire or coil or either magnet is moved, right? Let's suppose if movement is very fast, so what will be the magnitude of induced EMF? Is it greater or less?
Greater?
Yes, if you move the magnet very fast or the coil very fast through the field, so the value of induced EMF will be greater. And if you move that conductor or that magnet very slowly through the field, so there will be less amount of induced EMF, right? So if we further discuss about their key points, so we can write as number one, increasing the speed. ठीक है, बहुत बेसिक से कॉन्सेप्ट्स हैं यहाँ पर कि अगर आप स्पीड को इंक्रीज करते हो, सो इंक्रीजिंग द स्पीड विल increase the rate at which the magnetic field are cut, right? And due to the change in speed of the conductor or the wire or the magnet, it will increase the induced potential difference. ठीक है, आप जितना फास्ट कंडक्टर को मूव करोगे, जितना फास्ट आप कॉइल को मूव करोगे, सो देयर विल बी अ हाई वैल्यू ऑफ इंड्यूस्ड ईएमएफ और induced potential difference in the conductor or in the wire. Okay, so this is the first basic factor which affect the
Sir, can
electromagnetic
you
induction.
explain that point again?
The speed or the second point?
Polarity. The induced potential difference.
Induced potential difference. Okay, so if you talk about the induced EMF, so induced EMF is about the energy or the work done on a unit charge, right? And when this EMF will, or if you talk about the motion of charges, so when charge start moving into the conductor, so that EMF will become the potential difference, right? जिस तरह हमने नॉर्मल प्रैक्टिकल इलेक्ट्रिसिटी में डिस्कस किया था कि ईएमएफ जो है वो सिर्फ आपके पास एनर्जी प्रोवाइड करता है चार्ज को टू मूव इनटू द सर्किट, राइट? और जब कंप्लीट सर्कुलेशन हो जाएगी चार्ज की कॉइल में, सो देयर विल बी अ डिफरेंस बिटवीन हाई एंड लो पोटेंशियल, एंड दैट डिफरेंस इज नोन एज पोटेंशियल डिफरेंस, राइट? और लास्ट अगर आपको याद हो कि जब हम डिस्कस कर रहे थे डायग्राम में, तो प्रैक्टिकल डिमॉन्स्ट्रेशन में देयर विल बी अ वोल्ट मीटर कनेक्टेड विद द कॉइल. So both terminals of the wire are connected with voltmeter. So one will be the positive side and other will be the negative side, right? So आप अगर initially बात करते हो तो initially it will be induced EMF, और after the charge circulate into the whole circuit, so there will be a value of potential difference, right? Any confusion?
No.
Okay. अच्छा, पोटेंशियल डिफरेंस ईएमएफ का बेसिक कॉन्सेप्ट सेम है जो हम लास्ट डिस्कस कर चुके हैं. ठीक है, अब यहाँ पे इंड्यूस्ड ईएमएफ हम इसलिए लिखते हैं क्योंकि हम इनिशियल बात कर रहे हैं कि जब आपके पास इनिशियली इंड्यूस होगा, और फिर फाइनली जब आप कंप्लीट सर्कुलेट करवा लोगे चार्जेस को पूरे सर्किट में, सो देन वी विल टेक द टर्म ऑफ पोटेंशियल डिफरेंस, राइट। आप यहाँ पे इंड्यूस्ड ईएमएफ भी लिखो तो वो भी सही है, आप ईएमएफ के रेफरेंस से भी लिख सकते हो, और यू कैन ऑल्सो राइट विद द रेफरेंस ऑफ पोटेंशियल डिफरेंस। ओके,
Okay.
और व्हाट विल बी द सेकंड फैक्टर, एनी आइडिया?
Voltage?
वोल्टेज। अच्छा देखो, अभी हम जो कंडीशन डिस्कस कर रहे हैं ना, so there will be no power supply, there will be no energy source connected into the circuit, right? We are generating induced EMF or induced potential difference with the help of magnetic field, right?
Yes.
So there is only magnetic field and there is a coil and just a voltmeter connected with the circuit to find out the value of induced EMF. So there will be no power supply, no cell, no battery, no AC supply is connected to the circuit, right? सो हम करंट वोल्टेज और ये सब चीजें हम बेसिक यूज नहीं कर रहे क्योंकि ये तो हमें फाइनली प्रोडक्ट में मिल रहा है, ठीक है।
Yes.
सो सेकंड फैक्टर आपके पास ये होता है, लेट सपोज इफ वी इंक्रीज द नंबर ऑफ टर्न्स इन द कॉइल, राइट। लेट सपोज जिस तरह से हम डिस्कस करते हैं रेजिस्टेंस को, दैट इफ द लेंथ ऑफ द वायर इज इंक्रीज सो रेजिस्टेंस विल आल्सो इंक्रीज because the number of electrons and the number of atoms will also increase, so there will be great overlapping and great value of friction over there. So इसी तरह से सेम अगर आप नंबर ऑफ टर्न्स को इंक्रीज करते हो या वायर की लेंथ को इंक्रीज कर देते हो, सो वायर की लेंथ इंक्रीज करने से क्या होगा कि आप ग्रेटर नंबर ऑफ लूप्स जनरेट कर सकते हो। लेट्स सपोज एक सिंगल वायर में अगर 5 टर्न्स है और सेकंड वायर में आपने 15 टर्न्स लिए, ठीक है, तो आपके पास नंबर ऑफ चार्जेस डिफरेंट होंगे दोनों में, नंबर ऑफ फ्री इलेक्ट्रॉन्स डिफरेंट होंगे, और जब आप मैग्नेट को वहां मूव करोगे तो जहाँ पे ग्रेटर नंबर ऑफ लूप्स होंगे, so there will be a high value of induced EMF, right? So the second factor is related to number of turns. Number of turns is the second factor, and number of turns means, okay, am I audible?
Yes.
Okay, so we are talking about the number of turns. So increasing the number of turns will increasing the number of turns will increase the
Sir, your
magnitude.
screen isn't visible.
Now is it visible?
Yes.
Okay. So increasing the number of turns will also increase the magnitude of induced EMF, right? Or let's suppose if we take the example of two coils. So here's the example of two coil. Let's suppose if there is a coil 1 and the number of turns in coil 1 will be like this: 1, 2, 3, 4, 5. So there are 5 number of turns in coil 1, and if we take the example of coil 2, so there will be greater number of loops: 1, 2, 3, 4, 5, 6, 7. So in coil 2 there will be greater number of loops as compared to the wire 1 or the coil 1. So whenever you try to move the magnet through coil 1 or through coil 2, so second coil will produce greater or the highest magnitude of induced EMF as compared to the coil 1, right? और अगर आपसे इसका रीजन पूछा जाए तो ऐसा क्यों होगा? सेकंड कॉइल में आपके पास ग्रेटर वैल्यू क्यों इंड्यूस होगी ईएमएफ की फर्स्ट वाले की कंपैरिजन में?
Because there's more area.
यस। और मैग्नेटिक फील्ड को भी ज्यादा स्पेस मिलेगा, क्योंकि मैग्नेटिक फील्ड चेंज होगी तो आपके पास इंड्यूस्ड ईएमएफ होगा, राइट? अगर एक सिंगल लूप हो और एक सिंगल लूप से हम मैग्नेट को पास करें तो वहां पर बहुत माइनर सा चेंज आएगा मैग्नेटिक फील्ड के चेंज में, राइट? माइनर सा इफेक्ट होगा क्योंकि आपके पास कॉइल में नंबर ऑफ एटम्स, नंबर ऑफ इलेक्ट्रॉन्स बहुत लेस होंगे और मैग्नेटिक फील्ड वहां से बहुत शॉर्ट चेंज शो करेगी। और अगर आप पूरी फील्ड को कवर कर रहे हो और ग्रेटर नंबर ऑफ टर्न्स यूज कर रहे हो आप कॉइल में, तो जब आप मैग्नेट को वहां से क्रॉस करोगे सो मैग्नेटिक फील्ड काफी डिस्टेंस तक जो है वो चेंज होगी और काफी डिस्टेंस तक वो उसको कट करते हुए मूव करेगी। सो देयर विल बी अ हायर वैल्यू ऑफ इंड्यूस्ड ईएमएफ, राइट? ओके।
Yes.
एनी कंफ्यूजन?
No.
तो कॉइल वन में आपके पास ग्रेटर ईएमएफ होगा एज कंपेयर टू कॉइल 2, राइट?
But say there are more coils in coil 2.
Okay, so there is greater number of turns, so we can just shuffle these values. So coil 2 has greater EMF as compared to coil 1, right? Because coil 1 has less number of turns and coil 2 has greater number of turns, right?
Yeah.
कंफ्यूजन तो नहीं है कोई? मुश्किल तो नहीं लग रहा कॉन्सेप्ट?
No.
ओके। बस आपने वो जो लास्ट हमने डेमोन्स्ट्रेशन की थी और वो फिगर बस माइंड में रखनी है, सिंपल ये जो अभी कॉइल 1 और 2 में हमने ड्रॉ की है। और एक चीज बस इंपॉर्टेंट याद यहाँ पे ये रखना है कि अभी हमारे पास कोई भी एनर्जी सोर्स नहीं है, कोई भी इलेक्ट्रिसिटी सोर्स हम यूज नहीं कर रहे, कोई भी हम पावर सप्लाई यूज नहीं कर रहे। हम मैग्नेटिक फील्ड से इलेक्ट्रिक करंट जनरेट कर रहे हैं इन सिंपल वर्ड्स, राइट? और सिंपल वर्ड्स में हम यूज करें तो अगर हम मैग्नेट को मूव करते हैं या कॉइल को मूव करते हैं सो दैट विल बी आवर मैकेनिकल एनर्जी। सो हम मैकेनिकल एनर्जी से इलेक्ट्रिकल एनर्जी प्रोड्यूस कर रहे हैं इन सिंपल वर्ड्स, राइट?
Yes.
और थर्ड फैक्टर क्या हो सकता है आपके पास? अब वही कॉइल मैग्नेट को आपने माइंड में रखते हैं और थर्ड फैक्टर आपके पास क्या हो सकता है? अच्छा, एक तो नंबर ऑफ टर्न्स आपने इंक्रीज कर दिए, राइट? और अब देखो आपके पास जिस तरह रेजिस्टेंस के फैक्टर्स थे ना, अब रेजिस्टेंस में भी क्या था, लेंथ था फिर क्रॉस सेक्शनल एरिया। तो इसका मतलब है कि एरिया का इफेक्ट जो है वो आपके पास इंड्यूस्ड ईएमएफ पर भी होगा, राइट?
Yes.
सो इफ वी इंक्रीज द साइज ऑफ द कॉइल और इफ वी इंक्रीज द एरिया ऑफ द कॉइल, इट विल आल्सो इंक्रीज द इंड्यूस्ड पोटेंशियल डिफरेंस और इंड्यूस्ड ईएमएफ, राइट? सो पॉइंट नंबर 3, yes, point number 3 or the third factor, it is related to the size or the area of a coil, right? And if you want to explain this phenomena, so it will be like this. Increasing the size increasing the size or cross-sectional area of the coil will increase the magnitude of induced EMF, right? And the reason was the same, that if the area or the size of the wire will increase, so there will be more area or more size of the wire that will cut the magnetic field, so there will be greater change, or there will be a great change in the magnetic field. So that's why there will be a high magnitude or greater magnitude of the induced EMF in the wire. Okay. Any other
Yes.
factor? There are two more factors. First, we discuss about the speed that is related with the magnet or the conductor which we are moving in the field, and the other two factors are related with the nature of the wire, right? So, if we further think about the nature of the magnet, so let's suppose if there are two magnets, one is the weaker one and second one is the strong magnet, right? So strong magnet will produce a strong magnetic field, right? So there will be a great change in magnetic field when we pass the strong magnet through the coil as compared to the weak magnet, which has very low magnetic field. And when we pass that weak magnet through the coil, so there will be less value of induced EMF, right?
Yes.
So factor number 4 is related with the strength of magnetic field. Strength of magnetic field, and all factors are directly proportional to the induced EMF, right? Because in every factor, we discussed that by increasing the one factor, two factor, or three factor, the value of induced EMF will increase. It means that all factors are directly proportional to induced EMF, right?
Yes.
So in factor number 4, it is also directly proportional, increasing the strength of the magnetic field, increasing the strength of the magnetic field will increase the magnitude of induced potential difference or EMF, right? And what will be the last factor?
Type of magnet?
Type of magnet.
No.
Actually, we already discussed in factor number 4, that is related to the strength of magnetic field. And strength means if we use weak magnet, so there will be weak strength of magnet field. And if we use strong magnet or a good magnet, so there will be a strong magnetic field. So factor number 5 is related with the orientation of the magnet, right? Orientation of the magnet. If you remember, when we move the magnet in the forward direction, so the orientation or the direction of the induced EMF in a single line, and when you reverse the direction of magnet, so there will be a reverse direction of induced EMF in the circuit, right? So it also depends upon the orientation of the magnet. Okay.
Yes.
So it means that by reversing the, direction in which the wire or the coil or magnet is moved, right? So if you reverse the direction of magnet, wire or coil, so it will also change the direction of induced EMF or induced potential difference, right? So it will not affect the magnitude, it will affect the direction of induced EMF or induced potential difference, right? Any confusion?
No.
So these are the five factors. You need to remember about these factors because in MCQs and in detailed questions, they ask about the factors. They also ask you to write any three factor which will affect the induced EMF. And like of questions you already know we discuss about in the chapter of practical electricity, right?
Yes.
Okay.